Okay, today we're looking at the history of our atom. The model, or how we imagine our atom to look, it's fair to say has changed quite a bit over time. Let's go way back. The word atom comes from the Greek atomos, meaning indivisible. This is when we believed that atoms were the smallest thing that existed, and they were just these homogeneous neutral spheres. Since then, we've learned that smaller things in the atom also exist, like electrons. So we needed a model that incorporated electrons into our atom. Introducing the Plum Pudding model. Once again, another pudding ruined with fruit. Anyway, in this model, our pudding is the positively charged sphere, and our plums are the electrons distributed throughout. So overall, we have still got a neutrally charged atom. So that model of our atom was accepted until Rutherford came along. First, we need to consider his experimental setup. You need a vacuum chamber, a detector and scintillator surrounding your experiment, and an alpha source, a source of positively charged alpha particles. A very, very thin sheet of foil. Fancy. So the idea is quite simple. Shoot the alpha particles at the gold foil and see where they end up. Let's have a little look at the results. Some of my alpha particles went straight through. Some were deflected slightly by the foil, and very few alpha particles were reflected right back. That result was very shocking. It was likened to firing a bullet at some tissue paper and then expecting that bullet to bounce off the tissue paper and head back towards you. Okay, now let's have a look at the model that came from these results. We have a small, positively charged, dense core of our atom called the nucleus. Then we have loads of empty space, and then we have our electrons orbiting around this nucleus. Right, now we need to connect the two. It's really important in your GCSE that you make the correct links between the results and the conclusions of this experiment. So, those alpha particles that went straight through, that can be explained by the fact that my gold foil atoms are mostly empty space. My alpha particles pass straight through undeflected. And what about the ones that are deflected slightly? In that instance, the alpha particle comes quite near to the nucleus of our gold atom. Remember, my nucleus is full of protons and neutrons and is positively charged. So when my positively charged alpha particle comes towards my positively charged nucleus, it feels an electrostatic repulsion. That causes the alpha particle to be deflected slightly. Okay, and what about those reflected back? Well, since the nucleus is very, very small, few of the alpha particles that are sent towards the gold foil are headed directly head on with the nucleus of a gold atom. Those alpha particles therefore feel that electrostatic repulsion very strongly and are reflected back to where they came from. Okay, so that's the Rutherford model of our atom, but it doesn't tell me anything specific about my electrons. Introducing Bohr. Niels Bohr added the idea that my electrons orbit at set distances from the nucleus of my atom. This model is sometimes called the nuclear model of my atom. Well, that last model was a bit boring. Get it? Boring. So, is that it? Are we up to date with our model of the atom? Not quite. But for your GCSE, that's where we stop. If you enjoyed the video, please do like and subscribe. Please do download the notes. You'll find a really helpful table showing you the results of that alpha scattering experiment and the conclusions that you can draw from each of those results. Thanks for watching.